there is no beer. That's why we drink it here. And when we're gone from here, all our friends will be drinking all our beer.
Hello again. Last time we talked about our approach to economics. We talked specifically about three core principles that we know a priori from before proof. These are, you'll remember, the universal problem of scarcity, the challenge of self-interest, and the creative potential of human rationality. One of the most powerful things about rationality is the idea that people will respond to incentives in predictable ways. We're going to talk quite a bit about incentives in this class, so get comfortable with the concept. What we're talking about here is a structure of positive and negative feedback that accompanies various actions. Rewards and penalties, if you will. Incentives are tremendously important because they are going to be the main thing we look for in providing people the motivation both to do productive wealth-enhancing things and to avoid doing destructive wealth-limiting things. Incentives are all around us, and we'll be talking about many different types of incentives people face. But as you might expect with economics, one incentive we'll focus on in particular is monetary incentives, or prices. Prices are so important in economics that I almost hope you get tired of hearing about them by the end of this course. We'll get into a lot of detail about how prices work in the next few lessons. What we want to do today is explore where prices come from in the first place and what their basic meaning is in terms of the market value of a good or service. Now, as long as there's been trade, money, and prices, basically for all of human history, economists have been interested in the question of what determines the value of a good. And down through history, there have been a lot of interesting explanations, most of them wrong. Kind of like the geocentric theory of astronomy, that said the Earth is at the center of the universe. Wrong like those, in that they were seemingly plausible, but they could not quite explain the whole picture. And a better explanation was needed, one that always works. So in the theory of value, and note that in economics, we're talking about the price of a good as being its market value. Okay, and a theory of value that does always work in economics is known as marginal value theory. Marginal value theory has only been around for about 140 years, so quite recently in the grand scheme of things. And to get a sense of why this theory is so important and how it works, I'm going to start off by taking a look at how economists explained value or price before marginal theory. So we're going to go back to what existed before, which was the labor theory of value. And classical economists in the 18th and 19th century, people like Adam Smith and Karl Marx, used to think that the value of a good was determined by the amount of labor required to produce it. Now, it's a plausible explanation. It seems to make sense, and it works for almost all goods. Okay. Think about, for example, some of the most expensive cars in the world. Rolls-Royce, Bugatti, Lamborghini. And what do they have in common? They have lots of labor-intensive engineering, design. There's a lot of craftsmanship. And there's a lot of quality hand work that goes into the construction of these things. Okay, whereas your cheaper mass market cars are cranked out on a robotic assembly line, as little human labor as possible, using cheaper materials, a lot less craftsmanship. Same thing applies to houses. Okay, big, fine houses have a lot of craftsmanship and detail work. Okay, a lot of labor inputs goes into this. Whereas your mobile home is cranked out in an assembly line. Okay, not a lot of craftsmanship, not a lot of detail work, as little labor as possible. And the same thing applies to food, clothing, education, any goods and services. Generally, the higher priced items involve more labor or more expensive labor inputs. But the labor theory of value is deceptive. It seems to fit most goods you can think of, but not all. And here's an example that I like. This is my totally rusted out 1955 Chevy pickup that I bought for $300 when I was in college. And I probably spent 100 hours working on the motor, and I could never get this thing to run for more than about 5 minutes before it sputtered out. Now, if my labor were worth even minimum wage, I should have increased the value of this truck. I worked on it. I put a lot of labor hours into it. But in fact, I wound up selling it for less than I had paid just because the thing was a piece of junk. Okay, probably went straight to the junkyard. Now, you probably have your own example. Maybe you spent hours working on a term paper, but you still got a bad grade. The fact is that just because time is spent does not mean value is created. So the labor theory does not always work. Value sometimes is not based on strictly the labor input. So we have to rethink the whole question of where value comes from. Another problem classical economists had with value theory was related in the so-called paradox of value. The paradox goes like this. Why are diamonds so much more valuable, pound for pound, than water, when water is necessary for life and diamonds are unessential, a mere luxury? This question vexed even the great Adam Smith, and the best Adam Smith could come up was to say that, well, goods have a use value that's based on what people could use them for, and an exchange value based on what you could sell them for. So he had a use value versus a market value. But that doesn't settle the paradox, okay? That doesn't explain why the market value would be so much higher than the use value for diamonds, because again, they're not essential for life, whereas water is. So how do we solve the paradox of value? We can't do it with the labor theory of value. We need something entirely new. And this brings us to the marginal theory of value. In the 1870s, three economists made a breakthrough by discovering a theory of value that could both resolve the paradox of value and, unlike the labor theory, would apply to the value of all goods at all times and all places. What they discovered was, you guessed it, the marginal value theory. Now, this advance in economics was so important that it has since been known as the marginalist revolution, and it forms the basis for modern economics that we are doing right now. The three economists who developed the marginal value theory were William Jevons, a British economist, Leon Walras, a Swiss economist, and Karl Menger, an Austrian economist. And by the way, you did have to have a beard to be a professional economist in the 1800s. Just kidding. I'm going to share Karl Menger's original explanation of marginal value theory with you. Why? Well, Jevons and Walras were high-level math guys, and they derived their theories with the use of intense equations. Menger, on the other hand, was a bit more down-to-earth, and he derived his version of marginal value theory with a simple story about a farmer and his grain. And even though the translation from Menger's 1870 textbook, originally in German, of course, might be a little hard to follow, trust me, it's easier than deriving the math, and I'll help you work through it. So here's the passage from Menger's book, Principles of Economics. An isolated farmer, after a rich harvest, has more than 200 bushels of wheat at his disposal. A portion of this secures him the maintenance of his own and his family's lives until the next harvest, and another portion the preservation of health. A third portion assures him seed grain for the next seeding. A fourth portion may be employed for the production of beer, whiskey, and other luxuries, and a fifth portion may be used for the fattening of his cattle. Several remaining bushels, which he cannot use further for these more important satisfactions, he allots to the feeding of pets in order to make the balance of his grain in some way useful. Now let me go ahead and show this in a table. Here you'll notice I've divided his crop of 200 bushels of wheat into 6 equal portions, 33 bushels, just to keep things simple. And I've listed each use for each portion that Menger laid out. So we've got the first 33 bushels used as food for survival. Okay, the second 33 bushels uses food for health. Okay, the idea here is there's a bare minimum of food that'll just get you by, but you need more food to have energy and health. Okay, third portion is the seed for next year's crop. The fourth portion is the luxury beverages, my favorite part. The fifth portion was for luxury food. Okay, that comes about through fattening cattle and adding meat to the diet. And then the rest is used for what I'll label as entertainment purposes. He's going to use it to feed some pets, to have some companionship out on his isolated farm. Okay, let's continue with the passage from the book. The farmer is therefore dependent upon the grain in his possession for satisfactions of very different degrees of importance. At first he secures with it his own and his family's lives, and then his own and his family's health. Beyond this, he secures with it the uninterrupted operation of his farm, an important foundation of his continuing welfare. Finally, he employs a portion of his grain for purposes of pleasure, and in so doing is again employing his grain for purposes that are very different degrees of importance to him. Okay, all Menger's doing here is stating what should be obvious. The first uses of the wheat are more important than the last uses. Okay, we're going to note that in our table as well. Food for survival, of course, the highest important use, and then food for health would be higher, but not as high. Seed would be pretty high, but not as high. Okay, luxury beverages, lower. Luxury food, lower still. Entertainment is going to be the lowest. We're just ranking the importance of these uses from highest to lowest. Okay, continuing on with the text. The question that now arises is, what, under the given conditions, is the value of a certain portion of the grain to our farmer? Will the bushels of grain that secure his own and his family's lives have a higher value to him than the bushels that enable him to seed his fields? And will the latter bushels have a greater value to him than the bushels of grain he employs for purposes of pleasure? No one will deny that the satisfactions that seem assured by the various portions of the available supply of grain are very unequal in importance. Yet no one will be able to maintain that some bushels of grain, those for instance with which the farmer will nourish himself and his family till the next harvest, will have a higher value to him than other bushels of the same quality, those for instance from which he will make luxury beverages. What Menger is saying now is that even though the uses to which the farmer puts the different portions of wheat can be drastically different in importance, for instance survival with the first units versus entertainment with the last, we can't say that the first 33 bushels are more valuable than the last 33 bushels. Why? Well, wheat is what we call a fungible commodity. This means every unit is equal in terms of its quality and usefulness to every other unit. And here's a definition, and let me give you a few more examples. Okay, money is a fungible good. Okay, I could give you a $10 bill, or I could give you two $5 bills that has the exact same functionality. Okay, I could give you 10 $1 bills. Maybe even a little better example, gasoline. I could give you a 5-gallon can, or I could give you 5 1-gallon cans. It might take a little longer to pour it, but you get the exact same amount of energy regardless of how it's packaged. Okay, and the exact same thing goes with wheat. A bushel is a bushel is a bushel, and as such, on the market, each bushel is going to have the same market price or value. Okay, one bushel of wheat, which is 60 pounds of wheat, isn't more useful than another bushel, because another bushel is, again, exactly 60 pounds. Okay, so with that point in mind, we'll continue with Menger's story. He says, we have been asking what value a given unit of a quantity of goods possessed by an economizing individual has for him. Our question can be more precisely stated with respect to the nature of value if it is stated in this form. Which satisfaction would not be attained if the economizing individual did not have the given unit at his disposal? That is, if he were to have command of a total amount smaller by that one unit. The answer, which follows from the previous exposition of the nature of human economy, is that every economizing individual would in this case, with the quantity of goods yet remaining to him, by all means satisfy his more important needs and forego satisfaction of the less important ones. Thus, of all the satisfactions previously obtained, only the one that has the smallest importance to him would now be unattained. Okay, now we're really getting somewhere. Menger is doing here what we call a thought experiment. It's a form of that a priori reasoning that makes economics so much fun, because this is something we can all do. Okay, we don't have to go and collect data to prove it. We can just use our own minds and do the same experiment in our own minds. Okay, let me go back to the table and show you what he's saying here. Okay, let's say the farmer's harvest is not so great and he's down one portion or 33 bushels. What does he do? Does he say, sorry kids, we can't eat this year, but at least we'll be able to keep Fido alive? I don't think so. It should be obvious that with one less portion of wheat available, our farmer will give up on the least important use of wheat. Okay. With two fewer portions, he gives up on the two lowest importance uses. If the harvest is down to, say, 133 bushels, okay, is he going to keep feeding the dogs? Is he going to keep fattening the cattle so he can have luxury food but not have enough basic food or not have any seed corn? Of course not. Okay, they're going to say bye-bye to Fido. If it's bad enough, they might have to get rid of the beef cows. Okay, if things are really bad and they're down to 100 bushels, they're going to have to give up on the luxury beverages. No! And notice now that the least important use, which is the seed grain for next year, that's a higher valued use. Okay, that's a high importance use. Now it's the least important. So if we're down to 100 bushels, the last use is now a fairly high importance use. Okay, so let's wrap up with Menger's story from the textbook, and then we'll be able to make a definitive statement about value. Menger concludes, accordingly, in every concrete case, of all the satisfactions secured by means of the whole quantity of a good at the disposal of an economizing individual, only those that have the least importance to him are dependent on the availability of a given portion of the whole quantity. Hence, the value to this person of any portion of the whole available quantity of the good is equal to the importance to him of the satisfactions of least importance among those assured by the whole quantity and achieved with an equal portion. What the heck did he just say there? And let me summarize this in terms of what I call the marginal value principle. The value of a good is based on its least important actual use. Think through it with me. With more wheat available, the farmer can use it for what? That's right, only less and less important uses. Likewise, the less wheat he has, the more important the uses for it, and the greater the unit value, down to the extreme case where he only has 33 bushels needed to keep himself and his family alive for 1 year. And that's an extremely valuable use. Okay, so let's now take the marginal value principle and apply it to that paradox of value regarding diamonds and water that we talked about a few minutes ago. We'll follow Menger's example and we'll just think through some possible uses of each good for the average family. Okay. Starting with water, let's say you have 1,000 gallons available per month, and for simplicity we'll divide it into 10 equal 100-gallon portions. Again, we're going to put it into a table and we're going to list through each portion, its use, and the importance of that use. Okay. What's the use of the first 100 gallons? I think we would all agree here that this is going to be drinking water for survival, and of course the importance will be extremely high. Now with the following uses, with the second, third, fourth uses, you might reorder things here according to your own individual preferences and values. Okay. These are just suggestions, but the second 100 gallons might be used for something like bathing, and that's still a pretty high use. That's for health. Okay, that's not just to impress the opposite sex. That's for health and sanitation. Okay, the third maybe for cooking. The fourth for cleaning, for laundry. Okay, again, you can rearrange those according to your own preferences. The fifth maybe gardening. Okay, the sixth is for more cleaning. Seventh for washing cars. Eighth maybe for watering your lawn. The ninth and 10th maybe something completely frivolous, completely trivial, like entertainment. Okay. Now, if you're down to 900 gallons 1 month, what do? You say, my kids must have their slip and slide, so I'm sorry, kids, we'll just have to wear dirty clothes this month. No, of course not. In reality, it's going to be, sorry, kids, no slip and slide. Go do something else for fun. Okay. Just like with Menger's farmer, as the available quantity dwindles, only the more important uses can be satisfied, and the unit value of the good goes up. As more of the good becomes available, you are able to indulge in less and less important uses, down to uses that are virtually negligible or trivial value. Okay, then let's do the same thing with diamonds. Let's say the average household is going to use 7 carats worth of diamonds, this time not in a month, but over their whole lifetime. The first use, I'm going to go with the wise words of Beyonce and suggest it's for an engagement ring. Next, perhaps as an anniversary gift, diamond earrings and maybe another gift, perhaps a diamond pendant. Okay, eventually we might get down to the point where we're giving Fluffy a diamond-studded dog collar, or perhaps we're putting the diamond-studded 22-inch rims on a pimped-out Escalade. But the logic still applies. If you're down 1 diamond, you drop the lowest importance and lowest value use. If you add diamonds, you can only add lower importance and hence lower value uses. Now we're almost home free here, and we're going to put this in a format that should be very familiar to you. Remember, the marginal value principle says the value of a good is based on its least important actual use. We can now add to that. As the quantity of a good available increases, the value of the next use goes down. Okay, and I'm going to go ahead and go to the chalkboard now, just to make this a little easier. I'm going to put on the vertical axis of my graph a simple value scale. I'm just going to say this represents the value of the good in question. Now we can't technically measure value. We can look at market price, which is market value. For now, we'll just realize that up here we're at a higher value, and down here we're at lower value. On the horizontal axis, then, we'll put quantity. Let's draw the graph of water. We want to start with the first unit of water. The value is going to basically be off the charts, because without your first few gallons of water for drinking, you're going to die. So the first unit of water is as valuable as a good can be. What happens though as we add more units of water? Well, the value is going to start declining. We're going to use additional units of water for less and less important things. And we'll connect these dots here to create a smooth graph of the value of water. And notice that it declines as we add more units. Up here at the 100th unit, the value is very low, not above 0. It's being used for something totally frivolous. So there's our value graph for water. Let's do the same thing for diamonds. First unit of diamonds, it'll have a fairly high value, but it's not going to be anywhere close to the value of water. And likewise, the value of diamonds declines, maybe not that much. As we add more units, it'll eventually get to the point as you add more and more units of diamonds where you're using them for fairly frivolous things. That might not even get as low as the last unit of water. But we'll notice the general shape of the diamond curve is going to look like this as well. Okay, so let's label these the marginal value curves for water, and diamonds. Now remember, the marginal value principle says the value is determined by the least important actual use of the good. So the only question left for us to consider is what determines the least important actual uses of these goods. This part will be pretty easy. All we have to do is ask ourselves how hard is it to get a hold of an extra unit of water. In this part of the world, it's not hard at all. Okay, water falls out of the sky. We get something like 40 inches of rain per year. Water is plentiful from wells, rivers, and lakes. I'm going to draw another line on the graph, and this one I'm going to label the availability curve of water. We want to notice that as the value of a good goes up, people have incentives to bring more of that good to market. So if water got very valuable around here, people would have incentives to pipe it in or to truck it in. You could go up to the Great Lakes and truck it down. So basically what we're going to see is the availability curve is going to look something like this. We've got very abundant local water up to a large quantity. At some point we get to a limit where we're using all the available local water, but that's going to be at a very large quantity. Okay, and we'll label this availability of water. Now we want to look at where the availability of water intersects the marginal value curve for water, and that's down here at a relatively low level. Now let's do the same thing for diamonds. Of course, diamonds are much harder to come by. You have to dig way down in the ground like the Seven Dwarves. Where a million diamonds shine. Of course, if the value is higher, people will strive harder to provide them, but this availability curve is not going to be nearly as responsive as that for water. Okay, so it's going to look something like this. We'll label this availability of diamonds. Just not nearly as many diamonds available on the quantity axis as there is water. So where, then, is the availability curve for diamonds intersect the marginal value curve? What's the lowest important actual use we observe? Well, look here, it's going to be quite a bit higher than it is for water. Okay, it's going to intersect higher on the value axis. We're going to label this the value of diamonds, and we're going to label this the value of water. So we see that based on the much larger availability of water, the value of water is way down here, whereas based on the much lower availability, even though its total value curve, notice, is at a much lower level, the value of diamonds is way up here. What about the total value? Diamond water paradox suggested that the total value of water is much higher than that of diamonds. Remember, the water is useful for life, where diamonds are just a luxury. So let's take a look at the total value, which of course is just going to be the area under the marginal value curve for water. So we'll color in here the total value of water. It's an area under the curve. It's a very large area. The total value is the value of every unit of water added up. Okay, we'll do the same thing for diamonds. It's going to be the area under the marginal value curve for diamonds. And again, it's the value of every unit added up. Technically, we can't do this, but we'll cheat a little bit for the purposes of illustrating. And what do we find here? The total value for water is much larger than the total value for diamonds, even though the marginal value of diamonds is far higher than the marginal value of water. The paradox is resolved all thanks to the marginal value theory. Oh, and by the way, you might notice something. Do these curves look familiar to you? You're thinking, geez, Professor Watts, those look like the supply and demand curves from my micro class. Well, you're correct. Marginal value theory is the basis of the supply and demand model, which I hope you're familiar with from micro, but now you hopefully understand in a deeper, more intuitive way. When we move on in the class, what we'll be doing is relabeling this as a supply of diamonds. And instead of calling this the value of water, we'll call it now the demand curve for water. And by the way, don't be surprised then to realize that the demand curve is also known as the marginal value curve, and the supply curve is known as the marginal cost curve. If you're still struggling with the marginal value theory, don't worry. We'll get back. We'll cover this again in much greater detail. This is the supply and demand model, which is just a graphical representation of the marginal value theory in the next lesson as we develop the theory of market prices.
In heaven there is no beer. That's why we drink it here. And when we're gone from here, all our friends will be drinking all our beer. In heaven